Welcome to the DIY Honda Garage channel. The DTC P16F3 indicates a low voltage issue in the starter cut relay 1 control circuit. This occurs when the vehicle's powertrain control module, PCM, detects an abnormality in the return signal from the starter cut relay when the starter is supposed to be off. In a functional starting system, the relay acts as a switch to manage power supply to the engine's starter motor. Its proper operation is crucial for the vehicle's starting process. If the circuit presents low voltage, it jeopardizes the relay's capability to function, which may prevent the engine from starting. The relay circuit board is usually situated near the engine or power distribution center, and its connectivity must be ensured for proper routing of the signals. Therefore, accurate diagnosis is critical to pinpoint the issue and restore normal operation. The DTC P16F3 is tied to the starter cut relay 1 malfunction that has been identified by the PCM, which stands for Powertrain Control Module. This system is responsible for ensuring the appropriate functions of the engine's control systems. The error emerges when the return signal from the starter cut relay, which should be high or off when not engaged, has low voltage. This abnormality leads the PCM to initiate fault detection. A malfunctioning starter cut relay can inhibit the vehicle from starting, leading to significant inconvenience for the vehicle owner. Identifying the exact location of the relay and its wiring is important, since it provides insight into potential points of failure in the starting circuit. Several conditions might trigger the DTC P16F3. First, wiring issues may include frayed, broken, or shorted wires affecting power delivery to the starter cut relay. These connections are essential for ensuring proper operation. Any disruption can lead to voltage drops. Second, the relay itself may fail due to internal faults, resulting in it not performing its task of connecting or disconnecting power to the starter motor effectively. Third, there might be a fault in the PCM, the unit overseeing fault detection, which can misinterpret normal conditions as a fault. Diagnosing these possibilities is crucial to accurately resolving the problem and preventing further electrical issues within the vehicle. The primary symptom of DTC P15F3 is the inability to start the engine. When the starter cut relay does not receive the proper voltage signal, it fails to engage the starter motor, thereby preventing the engine from cranking. Additionally, the driver may hear abnormal sounds from the relay itself, such as clicks or buzzing noises, which indicate malfunction. Furthermore, dashboard warning lights may illuminate as the PCM detects irregular operations. Being aware of these symptoms allows for prompt attention to the situation, minimizing inconvenience and potential subsequent damage. It is essential to address these signs quickly to facilitate a smooth troubleshooting process. The first troubleshooting step involves turning the vehicle to the on mode to initiate electrical systems, including the starter cut relay's signal pathways. This prepares the vehicle's electrical systems for diagnostic inspection. In this state, you'll check the starter cut relay to see if it responds correctly to the vehicle's electrical conditions. Observing how the relay functions while in the on mode can reveal fundamental issues. It's crucial to ensure that the relay is receiving proper voltage levels and responding to the PCM signals accurately. A proper understanding of the relay's response will guide the next steps in troubleshooting. In this step of troubleshooting, you will perform an inspection of the external circuit, including both IG1 ST cut RLY and IG1 starter cut circuits. It is important to examine connections, wires, and the performance of these circuits for continuity and voltage integrity. Ensure that the circuit connections are secure and free from corrosion. as these factors can severely impact electrical performance. Additionally, the starter cut relay operation must be evaluated to determine if it is functioning correctly. If any issues are identified in the circuit, they must be resolved before moving forward in the diagnostic process. This step is essential to ensure that the electrical pathways are intact and able to support the proper operation of the starting system. In this stage, the goal is to connect and verify the PCM and relays functionality and the power supply signals flowing through these components. Disconnect relay circuit board connector B and PCM connector A to ensure safe access to the terminals. Once both connectors are secured, you'll conduct tests to verify that power supply signals are reaching the correct terminals. Observing voltage levels at indicated points while the vehicle is in the on mode will help confirm correct operation. If the power supply signals are found to be interrupted, it may indicate further issues in wiring or components that must be addressed. This step aligns with the goal of establishing that the starter cut relay receives power effectively and can operate as intended. Once the necessary repairs have been performed on the starter cut relay or associated components, it is vital to conduct a final verification check. This involves checking for diagnostic trouble codes, DTCs, to ensure the P16F3 code is cleared from the vehicle's memory. After clearance, a test drive should be performed to observe if the engine starts smoothly without returning the code. Monitoring engine performance during the drive will help ensure repairs were successful and that the vehicle operates correctly under real-world conditions. If no issues arise during the test drive, it confirms the necessary troubleshooting measures have effectively resolved the problem. For ongoing health of the starter cut relay and related components, establish a routine preventive maintenance schedule. Regular inspections of wiring, connectors, and the relay itself can help prevent problems before they arise. Checking for loose connections or corrosion will help maintain electrical integrity over time. Additionally, monitoring the vehicle's battery voltage is crucial. Low battery levels can contribute to issues in the starter circuit. So keeping the battery in good condition will support overall starting system health. Implementing these preventive measures will contribute to the longevity of the vehicle's electrical systems and enhance reliability. In conclusion, understanding DTC P16F3 revolves around the starter cut relay's low voltage issue, which communicates malfunction to the PCM. The primary objective during diagnostics is to locate interruptions in the relay circuit, which may stem from wiring faults, relay failures, or PCM issues. Recognizing symptoms, such as a non-starting engine or abnormal sounds, will assist in promptly addressing potential problems. Furthermore, instituting routine inspections aids in preventing future occurrences, ensuring the vehicle remains in optimal working condition. Therefore, thorough diagnostics and maintenance practices not only resolve immediate issues, but also contribute to sustaining vehicle performance and reliability over time. Please like and subscribe to the channel. See you next time.